my role in all this is basically to introduce Lizhi and put some context into why I've got an engineer talking to a bunch of plant breeders. Lizhi is a friend of mine, has been. He's been a collaborator of mine for the last 2 years. He's from the Department of Industrial and Manufacturing Systems Engineering. But mostly what I really hope to do through this joint presentation is to encourage you to step out of what you think is comfortable for you. Okay, so engineering and the mathematics, the applied mathematics that these guys use makes me pretty uncomfortable. Okay, but I think it's been well worth it. We've gone through some tough times over the last 2 years, and we're beginning to be productive now in terms of our collaborative research. What I want you to do is think about engineers not only for their ability to design useful technological tools to help you with the job you normally do, but to actually start thinking about engineers as true collaborators, as collaborators that can actually help you design and develop plant breeding processes. Okay, so we've tended to think about engineers as people who can build us little widgets that we can use to do what we normally do. But I want you to think about it a little bit further, okay, not just as builders of tools. And that's what we've done. I met Lizhi a little over 2.5, well, not quite 2.5, but a little over 2 years ago. We were riding around north central Iowa in a bus. And like all of those kinds of introductions, the first thing we do is we ask each other, well, what is it you do? And Lizhi asked me, okay, what is plant breeding? And I gave him some answer, something like this. You know, this comes out of Walt Fair's book, 1993 edition. This is a definition that's been around a really, really long time. When I learned it and learned the definition in 1982, or 81, or whenever I took my first plant breeding class, that was the definition we used. At the time, I didn't like it. I still don't like it. I really dislike this phrase, art and science. And now that I'm getting old enough to say so, I am saying so. I don't like that definition. I don't think that what we do is art and science. I can understand the art part of it. Quite often we can think about our germplasm as a palette, and from that palette, using various technologies, like an artist might use various brushes, we can create something that's never been created before. So the art I can get along with. Science is the part that I have a little bit more difficulty with. I'm not the first one to question this. There was an article published in Nature in 1945, so this is over 60 years ago, in which this definition was called into question. So go to Nature, 1945, David Lewis. Okay, and you'll see that David doesn't have much issue with art, but science is something that he has some issue with. Turns out that somebody else, who you all know quite well, Rex Bernardo, in his upcoming edition of his plant breeding text, has left out that, what I feel is an offensive phrase. He calls it plant breeding's genetic improvement of plants. He leaves out this art and science phrase. Now, Rex has his reasons for that, and he describes those in that chapter. I've had a chance to read his, get a preview of his book and look at it. And I leave it to you to look it up a little bit later. But what I would ask you to do is to think about plant breeding as actually designing processes that enable us to make decisions under limited resources. Okay, so we're trying to manage resources so that we can make decisions for the genetic improvement of crops. That, to me, is not so much science as it is engineering. And so I want you to start thinking about plant breeding Here I'm putting forth a proposition here. I'm putting forth a proposition that plant breeding is becoming like engineering. And thus, you know, my natural sort of affinity to go and visit with some engineers about what we do and ask them if they might know of ways to improve how we do our go through building these processes. And that's really the introduction that Lizhi and I started with. Then we sort of started working on a problem. We started talking about this problem of marker-assisted breeding. The goal of marker-assisted breeding is to improve the genetic gain, okay, the realized genetic gain. Now, I prefer this formulation of it. This is a formulation that the animal breeders prefer, and I like it also, where that center term is the correlation between not parent and offspring, although it could be. It's really the correlation between the predicted and the observed outcomes, okay? So that correlation is usually not very good, okay? And what we want to do is improve that correlation so that we can improve the genetic gain. Now, we also have to deal with, you know, that denominator where we want to minimize the amount of time and our costs. And these guys who work in engineering, they are all the time thinking about how do I maximize one thing while at the same time minimizing other things, and these things are pulling apart from each other, and how do we come to an optimum? Now, the marker-assisted breeding conceptual origins really came about you know, almost 50 years ago. A guy named Alan Robertson and his graduate students started talking about this in '61. Although we tend to think about it as, you know, as only being about 30 years old when Steve Tanksley and Charlie Stuber and Morris Soler started talking about these ideas. The initial theoretical development in this area was done by Rohan Fernando and Russ Landy, and they did this stuff about 20 years ago. After those sort of initial starts, there have been a number of applications developed. One of them is marker-assisted backcrossing. I tend to group these things into these three categories: marker-assisted backcrossing, gene pyramiding, and then various flavors of index selection, with the most recent one being genomic selection. So let's just take a quick look at how this works for something like marker-assisted backcrossing. Briefly, what we do is we tend to say something like, well, let's determine the relative efficiency between my method and the existing method, and you do a little algebra and you end up with an equation. Since we can get to the recurrent parent in only 3 generations, what we do is we say we can get there in about half the time as we would in using a phenotypic selection method. So I don't even have to be as good, that correlation coefficient doesn't have to be as good as phenotypic selection. I can be half as good and still get there if everything costs the same. Well, it turns out, though, that this correlation is actually better using markers than it is with phenotypes, or as good as. So this relationship tells me that we end up being about twice as fast using markers as we are using phenotypes using marker-assisted backcrossing. That's why it's used throughout the industry in converting transgenics, and it's even been used with native genes quite extensively, and I cite a couple examples here where it's been used by the Australians, and these have to do with wheat and barley lines.
Thank you for watching the Agronomist Podcast. YouTube limits video lengths to 10 minutes. You can watch this seminar in its entirety at the Department of Agronomy website, www.agron.iastate.edu.